this computer. So it's recording now. So this is the time we have to behave ourselves and say nothing that will be recorded.
Held against us, yeah.
So I wonder if, do we need to introduce ourselves again?
No,
No?
no. We
No, so
met
there's
before
no one
you.
new then. So how many are you? I can only see 3 of you.
Three.
3?
Great.
Okay, are you ready to get started?
Are you waiting for more people?
No, no.
Okay, let's get started then. So let me present. Okay, we've introduced ourselves, Alex and Linda. So this is the agenda for today. It's kind of got 4 parts. We're going to have a quick review of some things we did last time, and then a debrief on any lessons you might have done or any thoughts that you have about the last session, or how you're going to get started with teaching lessons. So that will be as long as we need. Then I'm going to introduce a little bit about the idea of how Let's Think is designed upon knowing about measuring the cognitive readiness of students, and how the cognitive demand of the lessons grows during the program, and what the design of the lesson schema are. Then Linda's going to do a cane lesson, one of the first, that's a grade 6 and 11, 12-year-old lesson called Roofs. And she's going to take you through it as students, and then sometimes we'll break out of that and have a discussion as teachers. Then we're going to, towards the end, look at like what the next steps need to be. We have one more training in a couple of weeks, but looking kind of to the future and to what you're going to probably do at the start of your school year, what the best things to get, and a bit of a discussion and look at questions. Everything okay so far? Yeah. Okay, so a bit of a review. We looked at this cycle. This is something I want to focus on, is how we focus on cognitive challenge. That's going to be a major part of what I explain about the Piagetian tests and the design of the lessons, how they involve social construction and metacognition. But your experience so far, have any of you taught some lessons since our last time? Have any of you tried the lesson that I demonstrated to you last time? No?
Not really.
No.
Not
So,
really.
okay, that's fine, because we're very early days. So we don't have too much to review then about your experience in your classroom, but are there any questions that you have about the last session, things that you're not clear about? Because I just want to kind of summarize where we are. We looked at this cycle. We looked at the difference and advantages and disadvantages of telling and finding out for yourself. We looked at the difference between showing and telling and exploring and trying to understand. What else did we look at? We looked at a lesson. We looked at the main concept of the lesson that was to do with variables, to do with values and relationships. And that's going to be a theme throughout all of the lessons, because they build on that idea in science and in maths. What else did we do? Well, we had a bit of a discussion about parts of the lesson. And then, thank you, you filled in the form. One teacher found it very difficult to apply what we did because they didn't teach science or maths. But I'm trying to remember, all 3 of you teach science and maths? Or
only the 2 of us.
Okay.
What does the other teacher teach? What?
Literature and language and literature.
Right.
Right, so we've done a bit of a review. Does it make sense what I said? I went through it quite quickly, but we had a long discussion about about telling and finding out. And that's going to be a theme we keep coming back to. When to tell, when to push students to find out. And that's going to be something in the next section. I think we're ready to go on with, and some of this is a bit of a history of CASE, but it's very important to get clear because of all the programs demand the idea that we understand where students are, their readiness, and the kind of demands of each part of the lessons. So I'm going to assume that you know a little bit about Piaget, or maybe a lot. I'm not going to spend a huge amount of time, but Piaget is famous for what's called the clinical method, where he would interview students and he would use various stimuli. Many of them are kind of scientific stimuli, to try to see where they are at in their growth and development. Well, the CASE people at Chelsea College and University of London, later became King's College, and throughout the United Kingdom, developed interviews that Piaget did, but as a group task. And you can do them with up to 30 students. I've done them with 30 students in a large room. And they're modeled on Piaget's interviews. You show them some stimuli, you see how they respond. And I'm going to show you those tasks. These are 4 of the 7 that have been the most used. And I've used them with maybe, I think, about 1,500 students in my career. Every class that I would take, no matter what age, I would use one of these tasks to begin with. And these are the kind of things that Piaget did. And I'm going to show you just a small part of one of them, which is the volume and heaviness task, which is quite well researched and also covers quite a range of early thinkers to slightly advanced thinkers. So it's one that is probably one of the best to get started with in the CASE program. All of these work on this principle. They are paper and pencil tests, but done when the tester is showing them things and giving them opportunities to ask questions, to interact with what they've been shown before they then answer individually on their own. And this is the very, very early part of this test. As you can see in the diagram, we have different shape and size vessels, typical laboratory equipment. And you physically show them, I fill a graduated cylinder to 100 milliliters, and then pour it into A. And then I fill the same graduated cylinder to 100 milliliters and pour it into X. Now, it would, for adults, it would seem obvious that each of them has exactly the same. And surprisingly, in grade 6, I found maybe 5% of the kids do not think that. They will say either A has more and X has less, or vice versa. They think that the height or the width is more important than the volume idea. And then we go on to a slightly more advanced question, same procedure. Each of these is filled and you show them being filled and using the graduated cylinder, and then they answer the questions. This is trying to find out if the students are at the stage where they conserve substance, where they have a conservation of volume idea. Make sense so far? And the students answer in private, and then later we can analyze their data. It moves on progressively, because remember, this test is sensitive to pre-concrete operation, level 1, up to early formal. And here together, we get a block of plasticine and you show it to the students. You have small cubes and you show that the block has 60. You ask them, you don't tell them first, you ask them to show they're working and say what the answer is. Then we agree that it's 60. because this is important for the rest of the test. And then it moves on through various parts. I'm not showing you them all, but the question here is, we have this block, they know it is 60 centimeters cubed. And what will happen when you put it into this graduated cylinder that's a liter high, absolutely filled to the brim? How much water will spill over? And some answer 60, some make up an answer. But this is when it gets very interesting, and exactly the same 60 cubic centimeters plasticine. You physically show them in. You've shown the water spilling over. We've done some other measurements with it to see how much the water rises. And then we'll roll it into a ball and then into a cylinder and ask them to predict how much the level will rise. Surprisingly now, 40 to 50% of my normal grade 6 students think that there's a difference in the volume to do with whether it's a round ball, a cylinder, or the original block. And then even more surprisingly to many, many science teachers I work with, we show them the same plasticine block and a metal block, an iron block or a brass block. It's not important that they're exactly the same volume, and you pass them around to the kids, take their time, they weigh the plasticine block and the metal block in their hands. And clearly most notice that one is heavier than the other or has more mass. And then the question is, which will spill over more? If the metal block is lowered in, will more, less, or the same as the plasticine spill over? And then you ask them to explain why. And they come up with concepts that show they understand heaviness and volume to be mixed together. Most of my 6th grade students predict the iron block will spill over more water, even though it's the same volume. A few students say it will make no difference. Now, if you do this with older students, with say grade 9 or grade 10, probably the majority will think that there will be no difference. This is based on Piaget's research, but it gives us lots and lots of data of students' development. And the final items become more and more abstract, and they depend upon the concept of density being distinguished from volume and heaviness. Now, those tests have been done with a huge sample in the 80s and 90s in the UK of 11,000 students across the school age range. The school age range in the compulsory school age range is from 6 to 16 during that time. And this is the kind of data that they came up with. And this was highly informative, because if we think from 14 onwards, and I'm sure it's the same in Bulgarian schools, that the science and the maths and many other subjects curriculum starts becoming more abstract, more detailed, and needs a higher level of thinking. So we have from 14 onwards, the curriculum will be making formal abstract demands. And so that's why I put the green line there to show the demand. But the data from this mass survey and many surveys since show that there's a gap between the readiness of the mean or the average student at 14 and the demands of the curriculum, which explains anyone that teaches those kind of grades know the demands are very, very high, and students struggle from 14 onwards in maths and science in particular. So this problem was revealed by the inventors of CASE and the cognitive acceleration. And their solution was to try to accelerate the development. To give you an example of that, this is work that I did in my own school in Zurich about 5 years ago with the Let's Think English program. this happened to be slightly younger students, the last year of primary in the primary years program, who then moved into grade 6 of the secondary middle years program. And the red line you can see has shown a change in what they've done in their Piagetian testing. This blue line is the mean that I showed you before from the 11,000 survey. And the blue, these are 2 standard deviations. And so that's a small example with one age group. But this has been done in many, many schools to show the crucial time. And these students were below the mean, and they end up a considerable amount above the mean. Okay, I think it's probably time before I move on. Any questions that people have about that? I'll try to summarize. They got Piaget's interviews, turned them into group tests. The assumption was any trained science teacher would be able to do them. And that they would give you very, very fruitful information about how ready your students were at different ages and where they fitted on a national profile. And this has been used often by teachers with their own classes. And it's one of the, I think one of the best ways to get started in the CASE program is to try out this test, this volume and heavy test with your 6th grade students. I said before, this is the design feature of the CASE lessons. They have, and Sarah talked about this, they have an entry level that is quite low in cognitive demand. They have a target level for most of the activity, and then a high target, the high ceiling, she called it. So each lesson is designed to pick kids up at the lower level and try to target them all to a difficulty beyond their present level of cognitive development. And this is done across a range of the schema, the formal operational schema that Piaget identified, which are very, very much the backbone of any maths and science curriculum anyway. This is the Piagetian levels, and these percentage figures are where your normal grade 6, or in the UK, they say year 7. Okay, I want you in your group of 3 to have a look and see what you noticed about the design of the 30 lessons, given we have this scale of demand or difficulty. We have different schemata that are to be developed. And we have each lesson has an entry, main target, and hopefully challenge level. So a few moments. What do you notice about the 30 lesson program, the schemata, and the demand? Is that clear? What do you see and what do you think is happening? Can I have a signal from you that it's clear to start discussing?
Not to everyone. Not really clear to all of us.
Okay. What do you notice? For instance, this is a group of lessons, the first 5, that are all about variables. And the lessons progress every second week you would do during your grade 6 or your year 7 in the UK. Do you notice anything about the design of the difficulty lessons? Then we have different schemata.
What I can notice is that the Piagetian level increases with every lesson of the group. So the first lesson has lower Piagetian level, then the next one is a higher level, and then each of the next one has higher and higher jump on.
For a group, so for instance, variables, that group the demand increases through that series of lessons. Yeah.
Same with classification, but there's one group, the compound variables, that's almost equally,
Някой даже пада.
Yeah.
and there is the equilibrium that goes down actually a little.
Може би correlation.
And also, yeah, correlation is going down
So
actually.
they don't always proceed, but is the general trend across the 2 years for increasing starting, middle, and higher demand?
Yeah, it starts from 2B and it goes to 3A.
Yeah, and remember, these are the, you call it grade 6 and grade 7 for the first 2 years of secondary?
Year 5 is actually the first.
Okay. So this is 11, 12, 13-year-olds
Yeah,
over this rate, yeah? And when we start, for instance, classification, or when we start proportionality, there's a kind of dropping down in the demand, because clearly the students, it's a new context, it's a new schema that we're trying to develop. They tend to start at a lower level. Clearly, once, and you will see that these 5 lessons are very, very structured in terms of how the demand and the concept grows. For instance, this is the first 5 lessons, looks at more linear here, but these are what the design of them is. You've seen the values and relationships was the first lesson. Very, very simple context, not very much science in it. A lot of thinking, but not the usual science concepts. This moves to 2 variables, and we introduce the idea qualitatively of input and output variable, or later we will start referring to it as independent and dependent variable. And then we move, the complexity gets into starting to quantify relationships, starting to look at linear increase or inverse increase and decrease. And then we move on to a greater number of variables to develop the fair testing idea, and then out into multivariate problems. Does that make sense in terms of the design? The language will be, each stage only has a small amount of new language. And that is made very concrete when they're taught, the language we use when they're just comparing words and they're not really quantifying and using numbers. And so at each stage, the demand increases, but we make sure that the amount of new language, new needs for thinking are kept to a minimum, so we can really focus on the thinking demands of the key concepts. Does that make sense? Yeah?
yeah.
And the same in each group. When we come to inverse proportionality, there's quite a steep curve. Now, many students are struggling to get to even the target level.
Самата дума инверс е обратно пропорционално. Okay, sorry.
We just made clear something in Bulgarian, yeah.
Yeah, okay. And so the design of the program is that we're constantly trying to introduce new demand, but manage the demand so that the students are not confused with a huge amount of new content, of new scientific ideas, but they're being trained in the ways of thinking. And often at the end of the first year, after 15 lessons, I would repeat one of the Piagetian tests to see if what I'm observing in the lessons and in other science lessons is evidenced by an increase in the sophistication of the students' ways of thinking. And these Piagetian tests especially the parts where they have to explain their thinking. And I often, because it's a class I'm teaching, will have a one-to-one conversation if the students are struggling to write down their thinking, because most of my classes were in an international school were very, very differentiated in their level of English. They would often have 3 or 4 languages. Okay, so that's the Piagetian measurement and design of the difficulty. So we're trying to match the demand just enough to stretch the students upwards in their thinking and to accelerate them beyond what would be the normal development, to give them a boost. In Finland, they talked about preparing the mind for new learning. And the people that worked with CASE did a lot of long-term measurement of this to show it took time to get the acceleration, where many people were saying, show us it works in 6 months or a year. Our idea is that it transfers to when the students get to the 14, 15, 16-year-old formal demands. And we showed you last time that played out in the national exams. Just the intervention early in secondary prepared their minds to be able to study and learn better later. Okay, that's me finished for this first part. That's the Piagetian theory, how it goes into practice, how we assess the development, and how that is embedded in the design of all of the CASE lessons. And similar thinking is in the CAME lessons. Okay, so before I hand over, chance for any thoughts or questions?
No.
Not at this moment.
No.
No, have I been clear enough?
Yes.
Yeah. And obviously each lesson can be used as a starting point for your normal science or maths, or if you're doing Let's Think English or literature lessons, because the idea is the students become more aware of their own thinking, and we as teachers start to get deeper into the minds of our students and their thinking. That's one of the powers of these lessons, is there an opportunity for you to see how their minds are at work. And we'll see this now with the lessons that Linda is going to stimulate with you. Okay, over to you, Linda.
Thank you. Well, you said you didn't have a chance to try the lessons, but did you read through this lesson that was sent to you, the one that was called Sports League? Did you read it or not?
No, we have not.
No, okay, well, why don't we do it together now then? Have you got some paper and a felt tip pen or something like that you can draw with?
Yeah.
Yes, we
You've
do.
got some. You do, okay. So I'm going to take you through the lesson, and you've already got this one. So after we've done it today, you will be able to compare how the lesson has been written with the way that I present it. Because as we said to you last week, that the focus is children's thinking. In this case, it's mathematical thinking. So there's maths involved. And we'll talk about that at the end, about what is the maths involved. But also we talked about that the way that the teacher presents the lessons, the pedagogy involved. How do I teach you? And think about, as Alex reminded you, how much telling am I doing? And how much am I allowing you as a group of people and individuals to work it out for yourselves? Okay, so here is the story. This is the hook that Sarah said last week. We've got to get the children interested, and I want you to be interested before we start the work. So we can imagine that there are a group of schools and they like to play football. and I'm sure you have the same in Bulgaria as we do in England, is that schools play each other. And where I worked in London, we were next door to Arsenal football team. And so we had lots of the children who liked Arsenal. I certainly liked Arsenal when Thierry Henry was working there, because I thought he was a very good role model for children. But of course, children like different teams. So to get over the problem of children arguing about what teams they like, we suggested that we took 3 local schools for a league. Now, the first thing we have to do is we have to make sure the students know what we're talking about. So can you talk to each other and tell me what you think a sports league is? What does it mean? Talk to each other, and then one of you can tell me in about 30 seconds. What does it mean, a sports league?
Даже аз най-малко знам за спорт.
В който отделните отбори се създават един структури и направят победител, който е най-добрият отбор. Обаче има разлика между лига и в единия случай всеки играе с всеки, а в другия случай има 2 отбора играят и 2 отбора и победители. Само че в лигата не знам как е точно кое. Май при лигата е, мисля, че всеки си играе срещу всеки, но това просто как е организирано няма да става. Просто може би за това, че има правила някакви, по които става
членуваш в тая лига, приемат ли те в тая лига?
Трябва да е първо някакъв сбор от определени от няколко отбора. Трябва да има правила, по които да се влиза и да се излиза.
Okay. Can you tell me? Have you agreed what a sports league means? One of you tell me.
Някакъв вид организация, някакъв вид спорт.
Okay, so it's according to us, it's a kind of an organization that
определен вид спорт.
That's into a specific kind of sport, and that organization includes different teams that are selected to participate in that event. They are different rounds. Okay, let's call them. Each of the teams participates by competing with other teams, and the best team would win a prize of the best team, being the best team.
Аз съм чувала за шампионска лига, Champion League.
Champion League. Okay, that's lovely. Thank you. Well, you can imagine that most children will want to talk about this. You may have 1 or 2 who are not interested in football, so you might choose a different sport. But generally, the children get talking, they like talking about this, and you've said something which is crucial to the lesson. The teams have to play each other. Now, even if you've got children who don't know about the leagues, they will be hearing what other groups have said, because I would organize my class that children would be in 3s and 4s, like you are, talking about this, and we would ask 1 or 2 of the groups to feedback. So even the children who are not secure about this will hear what's being said, and so they can join in with the lesson. There's no point in doing this lesson unless everybody has tuned in and is ready to see what's happening. Now, let's take that idea you've given me. The teams play each other. How do they do that? Can you again have a talk about how do they play each other? How many times do they play each other? Do they all play? Can you just have a quick chat about what does it mean when you say the teams play each other?
Da, trebuie să creați
Da.
seti.
Nu, seti, si igra seti. Što, 4 učilište, 2 mislim.
Ама накрая има шампион,
Да. Който има най-много обуви.
който има най-много обуве. Откажи, нищо не разбирам.
Ами срещат се по същото време, играят.
Okay, can you tell me?
Има организация.
Most probably each of the teams plays with all the other teams, and then the team that has the most wins the league.
Okay, so we play each other. Where do they play? How do you sort out where do the teams play?
There is a playground. Usually that's with specific measurements. It has to follow some standards.
Yeah. So if the schools are going to go to each other's schools, they're going to play in the playground. But how do you work out who goes to which school? How is that done in a league? How do you work that bit out?
There is a host and there is a guest team.
Excellent. That's a lovely way of saying. Alex, did you want to say something?
Just, yeah, a decision needs to be made, doesn't it? You asked them to consider how many times and how many games. And you said there are groups. And Linda said we started with just 3 schools. So we're not going to have groups. This simple sports league, are we?
So we're going to have just 3 teams. But you're quite right. We have hosts and we have guests. In England, we say it's home and away. And again, this is another thing that you may have to explain to those students who are not au fait with this sort of thing, that you have a host team and a host and as guests. Okay, so now I want you to do something on your paper. We're going to have 3 teams and we can call them A, B, and C. Then we don't have to argue about who we would like in our league. We have 3 teams. Can you make a diagram that shows how many games are played if the 3 teams are in this league and they're playing each other? And remember what you told me about guests and hosts. So I'd like a diagram.
Като диаграм. Кой с кого играе? Да правим комбинации ли?
I hope you're all doing your own versions.
Maybe we'll see.
And when you have done your diagram, please will you put the number of games, the total number of games that are played, just write it next to your diagram, how many games you think have been played altogether. Okay. Now, in a classroom, we would get the children, we have large pieces of paper and black felt tip pens so that they can come up and put them on the board for other children to see. Oh, Alex has got one. Okay. Alex, can you put that away for now? And we'll see yours in a minute.
Yeah.
Okay, so we get them up. The children have a chance to talk about their diagram. Let's have a look. Can we see yours? Or can you look at each other's and let's see. Let's see if we can see what yours look like.
This is mine.
That's a splendid diagram. Well done. Okay, thank you. Has anybody got another one that might be different?
Моето не е диаграма.
Една идея.
Okay. And this is
Oh, that, yes. That's quite similar to the other one. What about our other teacher? Has she done one?
I have, but my diagram is actually line.
Let me have a look.
Just a second. Can you see?
That's splendid. Absolutely splendid. Well done. Yes. Okay. Now, you hope if you do this with any class, you are going to get a whole range of results. Very similar to what you've done, or always a range. And what we're going to say to the children is, well, let's see whether you've got the same answers. So how many games do you think they played?
6 games.
Do you agree with that? Yes? Do you all think 6?
Yeah.
Yeah? And can you see on your diagram why it's 6? Can you count the 6 games?
Each team plays 2 games.
4 games.
Oh, what?
Well, so it's
Come and show us. That's a good idea.
we have the team A, team
Yes.
B, team C.
Yeah.
Team A plays with team B 2 times, once as a guest and once as a host. And
Yes.
then each of the other teams also plays 2 games with each of the other 2 teams. So each team participates in 4 games in total. The games are 6 because there are 2 games between A and B, 2 between B and C, and 2 between A and C.
Right, that's correct. That's clear. Thank you. And that's what we want to happen in the classroom, is that level of description in the children's own language. At this point, we're working at low level, getting the children engaged, getting them tuned into what we're doing. And we don't want to block that by introducing a language that they can't all access. So you've said that absolutely how you'd like the children to say it. Alex, can you show the next slide, please?
Yep.
Okay. So this was a class that I worked with a little while ago, and these were their diagrams. The top left-hand one, you will see that they have put a 3 next to it and crossed it out. What do you think happened there?
The student thought it was 4 teams and not just 3 teams.
Right, look at their diagram. What does the diagram show you? Top left. Can you?
Top left.
Top left, yeah.
Okay,
They've
then
got a 3 and crossed it out. Why do you think they've done that?
the child didn't realize each team had to be a guest and a host. So they only thought that each one plays with one team once, either as a host or a guest.
Excellent. That's exactly what happened. Now, just remember that diagram, because that's what one group of children showed the rest of the class. Then another group showed the bottom left.
No.
Slightly different.
Okay, it works.
It works. Okay, so they've got that diagram that showed that there was 6. And then the middle one, on the right, they've got 3. So what happened there?
It's just the same as the top left.
That's right. Now, so the children came and showed what they did. Now, the teacher could say, I could have said, well, some of you are right and some of you are wrong. This is right, 6 is right, and told the children. Now, if you imagine you're one of the children that thought it was 3, why does the teacher telling you you're wrong and it was 6 change your thinking? All it will do is it will make them feel I've got it wrong. So what we do here is we say to the children, well, goodness me, can the answer be 3? Can the answer be 6? Talk about that in your groups. And then what happens is what happened here. The children who did the top left one, change it to the top right one. because they realize, just as you said, you've got to play each other a guest and a host. So in a very short time, you've got the children correcting themselves, not because the teacher has told them, but because other children are showing them a diagram, a model that proves why the answer 3 can't be right, as long as they understand guest and host. If you hadn't got that at the beginning, this is why I made you talk to me about it, so they understand it. Alex.
And it could be that you could say, well, okay, it is right if you have a league where they don't go home and away. Why might that be a problem? So that could be an interesting discussion to say, your answer is okay, but it can be improved to make a fairer league. And so it gets rid of that idea of, oh, we're wrong, you know, it's an incentive to improve thinking rather than just get the right answer.
Okay, so we settle on that. We agree that there are 6 matches altogether. And then the next task is, what happens if you have 4 teams? Can you do a diagram to show how many matches there will be for 4 teams? Now, I've put down one here that was a development of the others. And what we say to the children is, you can stick to your diagram. You can do the one you did for 3 teams. Or if you like somebody else's method better, somebody else's diagram, you can use their diagram. Again, this gets over this notion of, oh, it's cheating. You've taken my idea. We want to take different ideas. So let's have a look at this one down there. Can you talk about that together and decide whether you think that's a very useful diagram? Is it easy to see how many games there are? And can you tell me how many games there are? So have a little chat together about that diagram down here on the bottom right.
За четвъртата говорим, нали? Дали е достатъчно ясно, можем ли да изборим игри?
Аз мисля, че е много ясно и както всяка стрелка е двойна, е 2 игри.
Да.
Така че,
Аз така си го бях
да, броим стрелките и умножаваме.
И умножаваме.
Okay, what do you want to tell me?
4, 6, 12 игри.
We think it's a very useful way of presenting the task, and each of the 2-sided arrows represent actually 2 games. So if we count the number of arrows and multiply by 2, then we'll get the number of the games. We have 6 arrows, multiply 2, that's 12 games in total.
Yeah, that's, now you see, what you're showing me now is that you're finding ways of counting up those matches quickly. You said to me, you take the arrows and then count them and multiply them by 2. Now, you're going to have some children who will see that quite quickly. You may have children that have to count every one and go round twice. And this is where you need to keep an ear out for listening to what the children are saying. How are they working that out? Okay, so we think it's quite a good model. I want you now to work together, and I want you to find out what happens with 5 teams and whether you want to use that model or whether you think you'd like one of the other models. So 3 or 4 minutes, you've got 5 teams now. Okay. Can you come and show me? Can you show everybody what your model looks like now, what your diagram looks like now? Can you take that off, Alex, for a minute? Alex, can you go back? Yeah, thank you. Oh, wow. Oh, wow. Look, we've got a very artistic presentation here. So that's for 5. How are we going to work out how many matches there are from that?
Each team gets 4 arrows that go to it. First of all, I put them all in a circle, and then from each team goes 1 arrow that goes to all of the other 4 teams.
Okay, now that's very helpful for us then. So each team, and we've got 5 of them, has 4 arrows going to it, and that will help us work out how many. Okay, did anybody have a different model? Did somebody try something different? Let's have a look. Right, so now this is different. Can you see? But is it showing the same information? Can you put it back again, please? Put it back.
Yeah.
Put it back.
Yes, it shows the same information, yes.
Okay, what's different about it?
It takes more space.
It takes more space, yes. Okay, but is it clear? Is it clear what's happening?
For me, yes.
It's quite clear.
And the others think it's clear. Now, did you think that the one you saw at the beginning was that clear?
I think that this looks more clear to someone who's not familiar with what's going on.
Okay, thank you. So thank you very much. Now, what about our 3rd member? Did you have another one? This is where you need black felt tip pens and a paper so we can all see. Right? Now tell us about that one. What do you think about that? Is it like one we've seen before?
Just like the first one.
Just like the first one. Okay. Right, well, we've come a long way now. We're now looking at 5 teams. I think we decided that there were 6 games, 6 matches when there were 3 teams. How many matches were there when there were 4 teams?
12.
12, okay. Hold on to that because we're going to be using that in a minute. Alex, next page, please. Okay, now, when I did this lesson, as I said a little while ago, one of the children, one group, came up with this diagram. Could you talk to each other about what this diagram shows and what you think about it? Talk to each other.
We think it's very, very clever.
I'll tell them, they're very clever. Okay.
Very simple.
Okay. Why? Why is it clever and why is it simple? Tell each other.
There are no arrows involved.
Yeah.
It shows clearly that each team plays with the other 2 teams and doesn't play with themselves.
Now you see, we haven't talked about that, have we? That hadn't cropped up with the with the other models. It's only when you see something like this that fact comes out. And
Yes.
which, okay. Now, when I've told you, I've not been truthful with you because when I did the lesson, nobody came up with this model. So rather than me saying to the class, well, I've got a much better model than yours, I told them what I told you, which is that when I was doing the lesson with another class, one group came up with this. So again, you're reinforcing the notion that you are not judging them. You're not saying one thing is better than another, but you are introducing something that's a slightly more abstract than the other diagrams. Okay. Now,
Can I just
Alex, go on.
Не го ли правят така на Шампионска лига точно по този начин? Изреждат отборите и ги... На мен ми се струва, че така го правят. I think it's an official way for the football leagues, like world champions. I think they present this way
I think you're right. And I think if you've got children who follow football or whatever it is, they may have seen a diagram like this.
maybe.
So you might get it in a lesson, but if you don't, you can introduce it in a non-judgmental way. But Alex wants to say something.
Going back to the models you showed us, I can see one model that you commented on takes up more space because each model was from the perspective of one team, wasn't it? So you had 5 kind of smaller models, and then the other 2 had one model that showed the global picture, the whole league picture. That could be an opportunity with your students to discuss that about the space, about the efficiency, about the idea of the perspective. And it might lead to the idea, which has just been said, of this is maybe the way the World Cup or FIFA do it, because they want to be able to see each individual team's program and the whole program. So I would ask the question, which of the models you have now seen allow you, first of all, to see it from the whole league perspective, the individual team, and I wouldn't do this with students, I will with you. What happens if the league grows to have 34 teams? Because these tournaments are always growing, aren't they, in terms of the numbers? So which model fulfills those 3 criteria? With students, I would maybe only use 1 or 2 of them. But for you, can you discuss now which model allows you to see one team's perspective, the whole league, and allows growth for the future?
Може би този.
Тук растеж, да. Това показва Ланки, а пък нашия показва цялата лига, ама не може да расте.
Да.
Okay, we are ready.
Okay, what do you think?
The one team perspective is Diana's diagram.
This one.
Lovely, yes.
Ours shows the whole league perspective, but doesn't allow any growth. And the one with the table that's shared now on the screen allows growing on the right and down with other teams.
No, yeah.
Because if you had 32 teams, your model would have to be very big to be able to see the individual arrows. The arrows would become a spider's web, yeah?
Yeah.
And that's what the children say, I can't fit any more in, or I can't count the lines. So they see that this notion of efficiency. Alex just said, efficient models. So you can end up with a model that is efficient. It shows you the same amount of information, but it has much more flexibility. So if I was going to do 5 or 4 or 5 teams here, what can I do? How could I very quickly extend this diagram for 4 or 5 teams?
We just add rows and columns.
Yeah, so you can just draw. Okay, well, we've come a long way now. We've gone from a very simple idea to representing it in a quite an abstract way. So we've moved on in that one way. Okay, Alex, next one, please. Okay, so our focus is going to change a bit now, and we're going to look at comparing the number of matches matched to the number of teams. So when we had 3 teams, we had 6 matches. 4 teams had how many?
12.
We agree that, do we? We all agree that?
Yes.
What happens with 5 matches? Can you talk to each other? Talk to each other about what number you think will be for 5. Look at your models, look at your diagrams, and how many matches will there be?
There are a few different logics that we can follow.
Right.
One logic is each of the teams plays with the number of the teams -1.
Okay.
I mean, the team itself. We don't play with our own team.
That's a nice description. Yeah, that's lovely. Okay, thank you. So
If we
each
have
team.
5 teams.
Yeah.
If we have 5 teams and each of them plays 4 games, that means 5 multiplied 4, that's 20 games.
Okay. Now, you would hope that you would have somebody or some of the pupils who would be able to speak and explain as clearly as you did. But what's happening here is you are beginning to make a generalization. You are saying each team plays 1 fewer than the whole number. That's a generalization. And you will have some children who can do that now, and you will have some children who are still at the stage of counting. So they will be counting on their diagram. You hope at this point they're able to use the more sophisticated diagram, but even so, they will be counting.
Yeah.
And the minute you put this on the board, when you have a table like this, the children will start looking at the numbers, and some of them will forget the context in which they're working, and they will just focus on the numbers. Now, I've written underneath here, number of matches for 5 teams, and I've had the answers 18, I've had the answers 24, and I've had the answer 20, which is what you gave me. Can you talk to each other about why do you think some children say 18? Why do some say 24? And you've told me why it would be 20. So can I have a quick chat about that?
Yeah, well, some children see that 12 is 6 plus 6, so they add 6 more and they get 18 as an answer. Other kids would guess that 6 multiplied 2 is 12, so they would multiply again, and that would give them 24 as an answer.
Can I just say that's really interesting, because you're spotting then that the students are making some kind of generalization. They're generalizing a pattern, but it's a false generalization, yeah?
Yes.
Yes.
So that's a very important path to follow of why is something wrong, not just that it is wrong. And again, it's not bad thinking, but it's trying out a solution to see how it fits, isn't it? It's a trial and error, which is okay. It's not wrong thinking, because in some context, that kind of thinking works, doesn't it? Where you have a steady progression. So it's a good opportunity to get students who give us oversimplified generalization before you move to a more sophisticated generalization. Does that make sense?
So we're going to go for 20, are we?
Yes.
Okay. Now, you said that you knew it was 20. Could you say that sentence again to us about how you knew it was 20?
Or another one? The same one?
Yeah, the same one. Why do you think it's 20?
Because we have 5 teams, and each of them plays with the other 4 teams. So we have 5 teams multiplied 4 games. That makes 20 games.
And your diagrams have showed that really nicely, because you can see each team and you saw the lines coming out, or you saw the matrix where you could see that each team plays the others. Okay, so shall we take that then as a helpful way of finding out how many matches are played?
There is one more simple way. There is one more simple way to do it as well.
Okay.
We have 5 teams and we have if we take the last diagram with the
Can you
table.
Alex, can you go back to the diagram before?
Yeah,
Our
so
matrix, okay.
in our case, we'll have 5 teams, so 5 rows and 5 columns.
Yeah.
That makes 25 squares in total, and we'll have 5 axes. That's the diagonal that forms there. So we'll just we'll subtract 5, those 5, and we'll have 25 minus 5. That makes 20 again.
И това е по-лесното ли?
5 по 5 минус 5.
Много по-лесно.
So it's 5 multiply 5 minus 5.
Okay, so having this diagram enables you to see that there's another way of working out how many there are. I have to say that comes much later with a lot of children. I've worked with students who are perhaps 15, 16 years old, and they may throw that in, but younger than that, that level of description comes much, much later. So don't worry if it doesn't. Don't worry if that doesn't come out. Okay, so now, can we go back to the other one, Alex, please? So you've now got a way, and you've got 2 ways of finding out how many matches there are for the number of teams. So we don't need diagrams anymore, I don't think, but if you want to use diagrams, this is what I'd be saying to the children. We think we've got a way of quickly calculating how many matches. Okay, so if there are 10 teams, how many matches will there be?
I ask something before we go.
Yes.
Okay. When we present the children this task, do we show them possible answers? 18, 24, 20, or without them?
No, I wrote those down because that's what the class told me. When I was collecting up the information, that's what we took. In our work, we always write down what the children tell us. We don't vet it at all. We don't change it. We put it down and we say to them, you discuss.
Yeah.
Okay. So here we are.
I totally agree. I just want to check my understanding.
Jolly good.
And so can I again say, it gives them an opportunity to say, oh, what we thought was this, and this is the logic, and that makes sense, but we now see that there's a flaw in our logic. And that is very important from the Piaget idea of understanding what something is to understanding what something isn't is very, very important. And starting to see that logic has to have a special power, but it's not a right or wrong, it's what's the best thinking to solve this problem, where another problem might need a different type of thinking. And that's really, really important much later. What type of thinking do I need to bring to suit the problem? Yeah.
That's important, yes. Okay, so let's go back to our task. We say to the children, 10 teams. So how many matches?
90.
Well done, 90. And you might at this point say, gosh, that was quick. How did you do that? And then we are reiterating what the rule is, or what the method is. Because don't forget what Alex has shown you. You've got children who are up here and you've got children who are down here. And it doesn't mean that everybody's thinking at this level, although they've talked about it and explained as well as you did to each other. Don't take for granted that that's inside everybody's head. So we take the opportunity to keep pushing this notion of explanation, of reasoning, how you've reasoned it. Okay, so then you can say to the children, I'm going to choose a few numbers, and you might quickly write on the board large numbers and say to them, how many matches? So if there were 100 teams, how many matches? Come on. 100.
9,900.
Yes, I think I agree with you. Yes. I mean, you may have that level of, and of course, and then you may have children who are doing the arithmetic in their head, but actually say 999. And so again, you can have a nice discussion with the children. Don't choose difficult numbers. Don't choose 97 or 95. The arithmetic gets in the way, but it's quite okay. So are you all right now so far with this bit of the lesson?
Yeah.
We are now going to go up even further. And we're going to, we've generalized. You've given us a sentence in words that allows us to work out how many matches. Mathematicians don't like words very much. They like using numbers and letters. And so, supposing there were n, supposing n, the letter n, represented the number of teams. So at this point, I write an n in this list. Underneath the number of tens, I put an n down. What would we say about the number of matches if we were using n as our variable, as our number? Thank you, Alex. Yes, we've got an n.
Толкова мачко. Формули трябва да се.
Okay, would somebody like to share what they've done? Or look at each other's? Why don't you look at each other's and see if you've written the same thing down?
Okay,
come on. Okay, let's see one of them. Show us, tell us one of them.
So I have two different ones.
Can we just look at the first one to start with? Right.
N multiply n minus 1 in bracket.
Right. Okay, stop. Now tell me how that very abstract piece of writing links with the sentence you gave me earlier.
N is the number of the teams. And we said that we take the number of the teams and multiply it by the number of the teams, but minus 1 because we don't play with our own team.
Okay. Can you see that that's a very direct link between abstract notation and words?
Yes, it is.
Okay. Now, you know, I'm sure you've experienced this, that there are a lot of children when they are solving algebraic equations have no idea that those n's and x's and y's and things like that have anything to do with real life or words. So this is maybe the first time they've come across this, the first time they're going to be using n as a variable, but it's linked to something real. And for some children, you might need to even go back to the diagrams again. N, that's the number of teams, and we're going to each, so when we had 5, n was our 5, and each played only 4 teams. They couldn't play 5 because that would mean playing themselves. So n, and we multiply it because that's the number of sets we've got by n minus 1. You really can't rush this stage, because there will be some children not following it. Of course there will, because their thinking they're not able to work at that abstract level. But it is worth spending a bit of time on it. Did the other two of you get the same statement, algebraic statement? Did you get that?
Yes.
You did. Okay. Shall we look at your second statement then? Come and show us your second one. Right, can you read that out?
So it's square n minus n.
Okay, so we would say, thanks, Alex, absolutely. I don't know how you read it in Bulgarian, but in English, we would say n squared minus n. What does that, why does n squared minus n work?
Because that comes from the table we had on the previous slide. We had n rows and n columns.
Yes.
We multiply them to find out how many squares we have in total.
Yeah.
And then we subtract the number of the teams, that's the diagonal.
That's nicely described. Thank you. Now, of course, if you're working with students who have been introduced to algebraic notation, they will use that little square, the small 2. But there are some children who see that but don't know the notation. So they could say, in everyday language, it's n times n minus n. That's absolutely fine. Don't get too worried if they're not using the algebraic notation. As long as they understand it's the number of teams multiplied by the number of teams minus the number of teams. And what's great about this is it's a lovely way into introducing algebraic notation. And again, you can say, mathematicians don't like writing things, so they've found a quick way of showing n multiplied by n, and it's written as n squared. You've got lots of opportunities here to develop other things. Now, that was an example of telling, wasn't it? I told you that n multiplied by n is written as n squared. So there is a place for some telling. I need to tell you that because that's a convention that all mathematicians use. Okay. Phew, we've come a long way. Somebody, you had your hand up. Sorry, what did you want to say? Okay, right. I'm going to stop and I want you to talk to each other just for 2 minutes about what you thought of that lesson, what happened, and whether you feel it would be something you could use. So just 2 minutes, have a quick chat about that.
И стъпка по стъпка започнахме от най-простото към по-сложното, като стигнем до това да имаме абстрактна платформа.
До дефиницията. И постоянно му даваше обратна връзка. Да. Вие казваше, примерно, не казвайте грешно, а задавайте въпроса, проверявайте, провокирайте с опит.
Okay, what do you think? Did you like it?
We enjoyed it a lot. We liked how it was constructed. It all started with a simple topic that most kids would be familiar with. Maybe some of them even fond of it. For some others who are not into sports, we first heard what sports league means, so that everyone would have the equal start. And then we started from the most simple example with only 3 teams, having a question actually that makes us think, or some kind of a puzzle that we need to figure out, and starting from the very simple one and make it more and more complex slowly using our previous experience that we already had. And finally, we reached to an abstract level, having the formula that we came up with at the end. We liked as well that all the trials are not errors, but trials, and they're also valuable.
Okay, I think that's interesting. Now, Alex has put up for you, this is the thinking chart that goes with this lesson. So we start at the bottom, and you can see how the lesson progresses. We haven't done the blue one yet. That bit's the last episode. And alongside is a little bit of help for you as the teacher to explain what's happening at each stage. Now, all the maths lessons are written in this way. We have the Piagetian levels at the side, and then we have a description of the lesson and what's happening at each episode. So when you're working with your lessons, it's always important to look at this to see what's happening so that you get a picture of what's going on and the challenge as it progresses. I'm not going to go through the last episode because Alex has got something he wants to do with you now, but I'll just tell you what the last episode is. It's, have we got it there, Alex? Can we show them algebra stories?
Algebra stories, yeah.
It's the page, it's one of the pages in this.
Algebra stories, yeah.
No, it's this lesson.
Yeah.
And
Yeah.
it's,
Yeah.
yeah, there we go. Thank you. This is the end of the lesson. And this is where we are using the fact that we've introduced the notion of a variable and that we can use it to represent anything. So we give the children some stories. So let's do the first one. Supposing there were n pupils in a club, what could n plus 5 mean? Make up a story. What could it mean? Somebody just give me a, for instance.
5 more joined the club.
5 more join the club. Okay. Now, it is very rare in traditional algebra lessons for them to be presented with something like this. Normally, it is an equation or an expression. So n plus 5 equals 20. What is n? So the whole focus is on manipulating symbols. What we're doing here is getting underneath the words and the expressions to see that they understand what that n means. What does the next one mean? There are P players in a team. What can P minus 3 mean? What could it mean?
3 of them were sick.
Okay, that's nice. You get, this is hilarious because you get such strange, you get some lovely answers. I mean, you get children who say, well, there were 3 players in a team, 3 hit each other and they got sent off. So you have, you know, but again, it doesn't matter what they say. It's the spirit of the thing.
Yes.
I want to tell you though, just to finish, and something I experienced. I was in a secondary girls' school, and the girls were 14 years old. So they had already been exposed to quite a lot of algebra work. And we were doing this lesson. And at one point, or I think it was a lesson similar to this, at one point I said to them, okay, so there are L, I think it was milk bottles. There were L milk bottles and somebody put another milk bottle in. How many are there now? What would you say if it was L for the milk bottles?
L plus 1.
Right. Several of the girls said to me, it's M. What's happening?
That's the letter in the alphabet.
Okay. So here were these girls who had had goodness knows how many hours of algebra work, whose thinking was, it was like a code. L was this and the next bit of the code was M. It just showed me, do not take anything for granted.
Yeah, and can I say, well, one of you is a science teacher, yeah? Do you teach biology?
No, chemistry.
Okay, but just, I've had this exactly that experience with teaching genetics, which uses a form of algebra in terms of hereditary. And that thing is still so common with 16, 17, 18-year-olds, where they still don't quite get that we try to match the symbol to help us do the reasoning, but often they've got a very concrete understanding of what the symbol means. And in chemistry, you have a huge amount of symbols that you have to kind of talk about, don't you? And ways of manipulating. And chemistry has its own special kind of algebra. And that adds to the complexity. So you can use the thinking that you saw in that lesson for your older students as well, because they often need a similar kind of rhythm of getting thinking and words and symbols out in the open, as you did with the ideas of the sports league. So that's something that's really, really important to think. I can use these techniques from CAME and CASE lessons and Let's Think English in my normal teaching, because the similar patterns of thinking that go on, as Linda's just said. Okay, Linda, are you?
Yeah, do you think you're going to be able to have a go at that lesson? I know our English teacher probably won't, but will the two of you, could you try that lesson before next time?
Which lesson is it?
This one, the sports league with some children. Could you try it with some children?
I would love to try it.
Okay, what about your colleague there? Can he try it?
I'm not sure now because we are at the end of the year.
Right. Well, if you can, now if you can do it, can the other two come in and watch you?
Yes, I don't mind.
Would that be possible? Because then you've got something to talk about at the end of the lesson, that about what happened, what did they notice? And of course, when you're teaching the lesson, you don't notice everything, do you? Lots of things happen that you miss. So they can be extra eyes and ears for you, and to write down what the children say, take examples of the children's work, and it becomes a little lesson study for the three of you to be involved. If you can do that, that would be wonderful.
What age should it be? What age should the
Well,
grade? What grade?
Okay, we've done this with 10 and 11-year-olds and up to 15 and 16-year-olds. So you choose.
And can I just make the point? And the lesson is similar but different depending upon the pace and the prior knowledge of the students. That's why the third episode is great for even older students, the algebraic part. So you can start very low, move through quickly if the students are ready. But the important thing is to find out how they respond to each stage. And don't worry if you don't get episode 3 done with the younger students.
No, that could be a separate lesson. Okay, would you like another lesson like this next time?
Yes.
Yes.
Okay, I'll choose a different one and we'll do another one next time. That's fine. Okay, thank you very much. I enjoyed that. Thank you.
Thank you.
Thank you very much.
Right, Alex, over to you.
Oh, okay. Remember this diagram about the cycle, and the lesson goes in phases. And Linda showed you in detail 2 phases and briefly the algebra stories. And can you talk amongst yourselves? Did you see how the lesson and the way Linda delivered it worked through this cycle with some very specific examples? Focus on cognitive challenge, social construction, and opportunities to do metacognition and bridging, to look at our own thinking and link it to something else. So can you come up with some specific parts of that lesson where you experienced getting focused on the cognitive challenge, social construction, and metacognition and bridging? I'll give you 2 minutes to discuss that, but please be very specific about what you experienced in the lesson. And then later we'll talk about maybe what students will experience. Okay, so any of these events in the 2 episodes that we did in detail. Okay?
Okay.
От този урок
Мисля,
Focus on Cognitive Challenge беше когато ни накараха да направим диаграма.
да.
Първата
И
диаграма.
после увеличиха броя отбор.
Да, това пак е. Да. Social Construction беше това трябва
Работим
да
и учим едни от други.
обсъждаме, да помислим какво е Sports League, да помислим какво е или да си сравним диаграмите, да помислим коя диаграма е най-добра.
Когато ни попитаха коя гледна точка.
Да, това пак трябва да се обсъдим.
Метакогнишън според мен беше.
Това не е ли накрая, когато вече
Когато се страхме.
Да, когато излязохме
Качили в
страх.
страх.
Ясно.
Когато направихме формула.
Да. Макар че би трябвало да има няколко кръга, може би по-скоро. След първата диаграма направихме social construction, когато решихме кое е вярно, кое не е вярно. После сме имали някъде metacognition, кое ще е metacognition.
Може би таблицата, която ни даде.
Metacognition е когато... Значи social construction е когато обсъждаме, metacognition е когато
Покажем
да, вярно.
Тази сме минали 2-3 пъти през този.
Ама имаме follow-up епизод, което е това е преди следващата стъпка.
Според мен таблицата беше...
Metacognition може би да...
Според мен таблицата дигна абстрактността за първи път.
Okay, are you ready to give us some examples?
Okay, the first focus on cognitive challenge that we experienced was finding out what sports league means. We had a social construction when we had to discuss on it, what exactly it means to the 3 of us.
Can I just interject? And we asked you to compare each other's models, yeah? That was social construction moving into some metacognition, yeah? Not just discussing, we were actually getting you to make your thinking visible.
Yeah, that was actually the next step when we had the next cognitive challenge, I think, which was build up the diagram. Can we consider those as 2 different cognitive challenges? Finding out what sports league means?
Oh, I think so, yeah. There were several cycles of cognitive challenge, wasn't there? Exactly the very concrete preparation of understanding, like the rules of the game, the rules of the problem, the home and away was part of getting that, yeah? And then using the diagram was really the second part of the first episode, wasn't it? Yeah, that's a good point you've said, because we might go through these cycles quite quickly, yeah? You might do 30 times in a lesson, depending upon the pace of the students and what they understand and don't understand, yeah?
We are still not sure what exactly metacognition and bridging.
And that's one of the reasons that it's something that's very, very much discussed, but I'm going to make it simpler in the sense of a lot of researchers and psychologists think that metacognition usually has these 3 parts to it, that we monitor, we look at our own thinking, which was the reason why we asked you to show diagrams to each other. So you are monitoring your thought patterns. And Linda had examples of how she got students to monitor by the diagrams and the answers. And you evaluate, you say, oh, that says 3 and that says 6. The thinking, well, is it a good answer? Yes, but it's ignored one of the rules, which was home and away. And so often we will do metacognition with the students as a group. And the idea is that they start thinking about their own thinking as a result of that. And then people agree, well, okay, evaluation and monitoring usually leads to you planning the next steps. And did you see that we did that in terms of planning how you would extend your thinking and apply it? So really it's making your thinking understandable to yourself, but we tend to do that by using social construction to help metacognition start, by getting people to, like for instance, Linda asked you to say again the words for the kind of function you were coming up with, which was the number of teams times the number of teams minus 1. She asked you to make your thinking very explicit and monitor it and evaluate it and then plan how you would use it. Does that make sense?
Yes.
Different perspectives, perspectives, one team perspective, whole league perspective, and growth perspective.
Yeah, that was an example of exploring your thinking.
Yeah.
And there's much discussion in the literature about individual metacognition and social metacognition. I think we believe that we practice it, the teacher models it, because we know more about our own thinking and thinking at class. So in a way, we act as a mirror to the class to show them their thinking back to themselves so they can learn how to monitor their own thinking, how to evaluate thinking, and plan the next moves. And so this is a part of the lessons that's not so obvious at first, but it is very, very important. And when we say evaluate, we don't mean good answer, bad answer. We're saying, okay, what is the thinking that led you to 18, for instance? Why did everyone not agree with that? They had different thinking. So they were showing their thinking to each other so they can help monitor, evaluate, and plan. And did you notice there, your request for information made me know that I needed to go to telling rather than finding out, because not everyone, it's not everyday talk about metacognition.
Mm.
And I just summarized many, many years of research that still people discuss the meaning of metacognition, but these 3 parts seem to be the ones that all educators seem to make sense with, but not necessarily in any particular order, because you can plan something and then monitor that it doesn't work out and evaluate how to do the next plan. So again, it's a cycle. A lot of teachers that I've trained say, oh, we always leave metacognition and bridging to the last, and we never seem to get around to it. And I say, well, you've got lots of opportunities very early on. For instance, when a student says, oh, I didn't know that you have to play home and away, they're already monitoring their lack of knowledge about you say, I don't know anything about football. I didn't know you have to do home and away, but it makes sense. So metacognition and bridging can be done whenever you need students to be aware of what they know and what they think. Okay, so do you have some other places? I've listed a lot of examples for you, but anywhere else? Because you obviously were doing your own metacognition, weren't you?
Yes.
And like hearing your responses to the table that Linda showed you with the crosses set off a lot of evaluation and planning, didn't it, in your minds? I think. I can't see in your minds, but what you came up with afterwards, it helped you plan your next steps, didn't it?
Definitely.
Yeah. Okay, so I want to end with a little bit more Piaget. This isn't heavy theory, but I'm going to try to relate it to this. The whole idea of cognitive challenge depends upon these three ideas that I'm going to try to explain, is how our minds assimilate new information or new problems, how they sometimes are not ready to deal with that new information and have to change their way of thinking. And this often leads to a new equilibrium, a new way of thinking. So this is just a very, very simple, and I'm not making any claims about the neurology of this, but it's well known that if something is not that significant, that's why I've used gray, something just boringly normal, we don't even notice it. It just falls straight out of our brain. And otherwise, we couldn't deal with life if we were noticing everything. Does that make some sense? Yeah? Like, do you know what's on the wall behind you? Are you aware of that you're sitting on a seat? You know, most of the world we don't pay attention to. And also, I've seen this where gray teaching that I've been doing is falling straight out of students' brains. Nothing is being assimilated, nothing is being accommodated. There is no disequilibrium, there's no problem, but no learning is going to happen. Also, sometimes something is so, and that's why I use red, so surprising or complex that we can't process it. Something amazing happens. Did you see that? And people can't even process it because it's so outside. Or if it's some mathematical formula that they've never seen, it's just too surprising, or it's not processable. Then there's the idea of assimilation. We already have in our brains somewhere some organized thoughts, and new information comes along, and we add it into that structure of thought. A lot of learning is like this, is just more information that doesn't really change too much about our brains. Piaget called this assimilation. But sometimes what's coming to us has somewhat surprising aspects to it. Things that we can pay attention to, but we don't quite know where to fit them in our brains. And this leads to a process of, we can pay attention to it. It's a problem that we want to try to sort out. An example would be with the three system that one group of students came up with. They can't quite fit into their mental structure until they're prompted by some talking, some social construction, looking at other students' solutions, will allow them to ask questions and to change their mental structure to accommodate, we say, the new way of thinking. An example would be, we taught them how to use the table. This has structured their thinking in a different way. It's added something from what they had before. So new information can be fitted into this. And we've reached what we call a new equilibrium. We can deal with number problems beyond 5, sports leagues beyond 5. A new structure of thought has been developed. And so back to here, that this is the kind of challenge. We want a challenge that doesn't knock the students out, that bit by bit, we're feeding them new information that they have to organize in new ways. And that was what happened throughout that sports league lesson. And also the social construction is hearing and seeing ideas that help them get this information that they couldn't deal with first into a new structure. Okay, that's a little short Piaget lesson. Does that make some sense to you? The idea of we want to challenge them, but not over challenge them. And we want to make tools available that will change the shape of their brains. So learning a new tool, a new way of representing the world to yourself, because that's what we're, in all of our subjects, we're teaching them new perspectives. You said before, the idea of perspectives. And so we're changing the representational tools to make sense of the world. And the idea is that the formal operational ways of thinking and that allow us to deal with much more complex and abstract world and organize in a way. Okay, that's the end of my little mini lecture on Piaget. Okay, so we'd like to finish with a bit of a debrief and some questions. And I said to Linda, I've got lots of questions about like what you see as your steps forward. It's the end of school year coming, and it's that always is a major priority, isn't it? But I'm thinking about your plans for next year and the preparation we can do to help you to get into the program. It's 4 or 5 lessons into the programs, so we can plan the next steps together. So do you have any questions? So these are general questions about anything we've done so far. I'll give you time to think about your questions. You can talk about your questions with each other in Bulgarian before you feed them back to us.
How many maths lessons are there in the Let's Think program?
Well, we have 2 files. We have the first file, which is really written for age, I say written for, you can use them with any age, but 10, 11, 12, 13-year-olds, and there are 24 lessons like that. Sports League comes from one of them. We then have a secondary file, which has, I think that's 24
30.
as well. That's 30. We have 30 lessons for the secondary file, but they overlap. So, for instance, that one on Sports League is more or less the same for both files, but other lessons start off and you do the beginning, the lesson like that quickly, and you move on to more challenging things. So you've really got about 50 lessons, 50 different lessons that you, well, perhaps 40, let's say 40 discrete lessons that you would be able to do. And of course, you will find that when you try a lesson, sometimes the students are very, very familiar with it, and you go much quicker, and therefore you can go further. Other lessons, if it's completely new to them, then you will have to spend much more time on it. So you will only know when you've taught the lessons and you've thought about what happened and how far you need to go. But there are quite a few to work through.
And as far as case for secondary, there are 30. And it's more complicated with primary, but there's about 30 primary lessons. But that leads me to question of, I forgot your name, who's the science teacher?
Vlad,
yeah. You know, I showed you the first 5 lessons on variables. I've worked with lots of schools and teachers who say they want to do that with all of their classes, grades 6, 7, 8, and 9, because they know that, especially with the IB program, which you're doing, yeah, is that they have to design their own investigations, and that they need to have those understandings of variables and numerical variables, non-numerical. And they've said that's worked really well for them, that they've taught just those 5 lessons 4 times to different age groups before they moved on to the later case lessons, because it was a very, very important, and there's a lot of research on this, that students struggle with the controlling of variables thinking. And they found that really successful because they had multiple chances at teaching those lessons, and they saw they had to teach them slightly differently with different age groups. And I found that a really, really good starting formula, rather than trying to do all 30 lessons just once.
Okay.
Are there any kids that get bored with the lessons if they're already familiar with the abstract idea behind it?
Sorry, I didn't get the first part of your question.
Are they bored? They get bored.
Yeah.
Do they
Okay. Well, I find that they're not bored if they're already quite familiar. The early episodes go very quickly, and I spend more time then with the teachers, getting them to focus on the metacognition and bridging, because they want to apply the thinking of the lesson to the materials that they're doing in their normal content lessons, that they're then spending some time applying that thinking to designing their own investigations. And so the first part is quite quick review in a way, but it's helpful for the teacher because it exposes when they don't really understand how to control variables. And it helps them help plan with the students and do metacognition with the students about their own investigations. I found that teachers say, yeah, case has really cracked a problem that we continually have, that students' inquiry skills are struggling because they don't have the fundamental thinking behind them. Does that make sense?
Yes.
Can I give an example? There is a maths lesson which is about circumference of circles, the size of circles. And you start off at a very simple level where the children use string to measure the diameter and the circumference of a circle. And they are just comparing the lengths of string. Very, very concrete level. Now, I did this lesson and it was 10-year-olds, and we were doing this, and there were 2 boys who just called out, "This is pi." So I said, well, what does that mean? And they said, well, it's wrote off a whole sort of 3-point so I could have just despaired or said, yes, that's what it is. But the way that I handled it and the way I sort of rescued the lesson was, okay, everybody else is measuring with string and they're coming up with these relationships. You've said it's pi. I want you to now sit down and decide how what you know about pi links with bits of string. Because when we do our feedback, they will be telling us about what they found out. And at the end, we'll ask you how all this is anything to do with pi. So the model is, normally in lessons, we work our way up. But for those 2 boys, they were here and they had to unpick their thinking to match with what was real, what was concrete. That was a challenge. That was a huge challenge for them because they recognized it was something to do with the ratio of diameter and circumference. They had experience of using pi, but the challenge for them to actually explain what was happening in pi was a real challenge for them. And I have to say, although I sort of I gulped when that came out, because you don't often have somebody saying that, as those boys left, they both said, "Oh, now I understand." And it just made the point, I think, that you may have an abstract, not even understand, an abstract knowledge, not even understanding, but it enabled them to unpick it. And I think that's what you're saying, Alex, isn't it? That,
Yeah.
you know, don't take for granted, even when they come out with a statement like it's pi, they have any clue whatsoever about the fundamentals of it, the thinking involved.
Okay.
One more question. The lessons, for example, we went through the whole sports league lesson, right? There is no part that we missed. Is the next lesson related to this one, or are they explaining different abstract ideas?
The lesson I'm going to do explores some algebra, but in a very, very different context. And so you'll see the thread of algebra being explored, but it is, you come at it from a different angle.
Can I just go back to a slide to answer that? So the web page, that you'll see some of the strands here. It's going slowly, our website, for some reason. But there are algebra strands. Oh, okay. Let me just show the contents that we have. There's algebra strands, things to do with number, things to do with area, later functions, geometry, trigonometry, correlation, statistics. So they don't always follow, but they're similar to the case lessons that I showed you, that they're themes of growth. Where did I have it here? Through the schema. So it's a similar kind of pattern. Case is probably more sequential than the cane. But what's interesting is that the thinking patterns are not distinct. The idea is the thinking that you do in probability and correlation links to what you've been doing in sports league, for instance, and algebra. And so it's kind of thinking across the different strands of mathematics, and similarly here, thinking across the different parts of science. And also the idea that correlation and probability are in chemistry, physics, and biology. And that algebraic thinking is needed in the other parts, like trigonometry and number and functions. Does that make sense? They're not, because the idea is that they're trying to improve thinking, not sequentially build knowledge. Does that make some sense?
Yes, it does.
Yeah, because remember, this is a thinking intervention. It's not a curriculum in the sense of, and this is why, back to your question about if students get bored or not, I found the teachers I've worked with always want to create their own case lessons using, for instance, this as a blueprint, that they start with something very simple about the topic, where they get very clear about the variables and the types. And this might be one lesson, just doing these 3 type case lessons as a preparation, and then getting onto multivariate problems might be 4 or 5 lessons where they're doing some lab work or designing investigations or doing some data analysis. So many teachers, once they've done these, say, this is a model for me to plan my curriculum around thinking principles. Okay?
Oh.
We're out of time, but I would really like you to give us some feedback. and I've shortened the feedback. It's the same feedback form, and you're allowed to add a second entry, and it's just bit.ly/LT Bulgaria. And that's the shortcut to it. So it'd be really helpful for us to get some feedback. And you might just add to the first feedback that you gave.
Sure.
Okay.
If you can let us know as well whether you've managed to teach the lesson. If you have, we can spend some time talking about what you did. But if it was too difficult and you couldn't fit it in, we obviously we won't do that. So just a little bit of information before, a few days beforehand, to let us know if you did it or not. Or you watched a lesson. If you can't teach it, perhaps you can watch. That would be nice.
Sure.
Okay.
So,
Look forward to seeing you again in
A couple of weeks.
Yeah.
Thank you. Thank you very much for your participation. Thank you.
Well, thank you.
Thank you.
Yeah, and I'll mail the link to the videos for the recording. So I need to stop the recording now, Linda. Yeah.
Yeah, fine.
Okay.
Thank you.
Stop recording.
What's happened?
Stop recording.